The first incident took place on a clear, moonless night as an airline jet approached Portland, Oregon. Some 25 miles north of the airport, the aircraft was given a radar vector heading for spacing and was cleared for a visual approach. The crew began a descent from 6,000 feet so as to arrive at a 9-mile final at 3,000 feet. Unlike the simulation you see here, the crew could not see the terrain below since it was such a dark night. They felt they were okay since they could see the lights of the airport and the city in the distance. On the enhanced Gpws display, terrain begins to show as the aircraft is still some 7 miles from danger. As you see, the aircraft was heading directly toward a 4,300-foot ridge. As the descent continues, more and more of the surrounding terrain is displayed in denser dot patterns, indicating closer proximity to the aircraft's altitude. "60 seconds and 3 miles away, the enhanced Gpws displays a bright yellow terrain threat.
Caution, terrain! Caution, terrain! Caution, terrain! Caution, terrain!"
At 30 seconds and nearly 2 miles, the bright red terrain threat is displayed, and the terrain pull-up warning is given.
Terrain, terrain! Pull up! Pull up!
Several seconds later, we hear the standard Gpws Mode 2 terrain warning,
Terrain, terrain! Pull up!
which the crew did receive and respond to, saving the aircraft.
Pull up!
This incident clearly shows the advantage enhanced Gpws would have provided by displaying terrain, giving much longer warning times, and greatly increasing situational awareness for the flight crew. Remember, this happened on a clear VFR night. The second incident also occurred near Portland, Oregon. Unlike the good weather simulation seen here, a heavy jet was flying in instrument conditions. As it was approaching Portland, it was given a radar vector heading and descent clearance from 14,000 feet to 10,000 feet, some 75 miles east of the airport. Unfortunately, confusion between controllers and flight crew over what clearances were actually given and received resulted in the aircraft heading directly toward 11,300-foot Mount Hood. On a 40-mile range setting, the enhanced Gpws display shows no terrain within 2,000 feet of the aircraft's altitude. The aircraft is now below 13,000 feet, and the top of Mount Hood begins to show. As the aircraft gets lower and closer, more of the mountain is displayed. At 60 seconds and 4 miles away, the bright yellow terrain threat is clearly shown, and the display range changes automatically to 10 miles.
Caution, terrain! Caution, terrain!
The flight crew would have heard the warning as we have here.
Caution, terrain! Caution, terrain!
At 30 seconds and over 2 miles away, the bright red terrain threat is displayed, and the terrain pull-up warning is given.
Terrain, terrain! Pull up! Pull up!
In the actual incident, the controllers and flight crew got the aircraft turned away and climbing approximately 3 miles and 1,000 feet below the peak of Mount Hood. Had the aircraft been equipped with enhanced Gpws, the flight crew would have seen a picture of their situation some 10 miles away and received warnings at both 4 miles and 2 miles. This incident is a classic controlled flight into terrain scenario, in that a number of factors combined to create the situation, and no single action by air traffic controllers or flight crew was responsible. In fact, the flight crew never saw the terrain they missed by only 45 seconds. The increased situational awareness provided by enhanced Gpws would likely have increased that margin by several minutes. It is clear that with enhanced GPWS, incidents like this could be avoided long before drastic action is required to save an aircraft.